So it's really exciting to be here today. I think so much of what you guys have not only demonstrated in your projects, but also just the findings today is really also inspiring to me, as well as our business, which is Renewable. So as Stephanie mentioned, I'm the Chief Executive Officer and founder of Renewable. And what I noticed back in 2012, working with students such as yourself back in Thurgood Marshall High School, located in Harlem, that in 2012, we were spending $77 million to export food waste from our schools, from our cafeterias, from food distributors in Hunts Point, Bronx, to send it to China, Pennsylvania, Virginia. And now, if you can imagine the carbon footprint behind that, it's incredibly large. Today, we spend roughly $186 million. And as more people live in urban areas, it's not only going to increase, but it also challenges us to rethink models of how we can use or upcycle food waste. And I'm going to explain to you one idea how Renewable decides to take on that challenge. And so what we do is we take the produce waste from food distributors and food processors that can't go to food banks or farms, and we turn it into plant-based hydroponic fertilizers. Now, you guys may have worked with fertilizers that are liquid or salt-based, and they're all coming from a very heavy industrial petroleum-based supply chain. I'll explain to you what that exactly means, but all that means is it creates a ton of greenhouse gas emissions, which increases our temperatures and only creates more problems for us in our future. So what we decided to do was to basically dehydrate the plant-based food waste. So we only take vegetative waste from fruit and vegetables, again, that can't be recovered, and we dry it, turning it into a pellet that will ultimately provide the sources of nutrients for our plants that we'll explain later in the form of nitrogen, phosphorus, and potassium. And we sell it direct to farms. So the same type of farms that you guys have in your schools, we sell it at large scale to vertical farms. This is an example of one that's roughly 100,000 square feet. Or you see one which is a tomato grow based in California. Large scale, able to help us not only grow food closer to cities, but have much more food per square foot being grown, and also use 90% less water, the same type of impact that you guys have in your schools. We also noticed that the same problem that we're trying to provide for the hydroponic farms, which is providing a plant-based, no manure or animal byproduct fertilizer, which makes it much less prone to having antibiotics and some of the other chemicals in our food. But those same problems or same type of demand for a type of product of ours for hydroponic farms was also being witnessed for soil-based farms in California, where they're growing an abundance of the world's food supply. But the problem is a lot of times because of the problems dealing with chicken litter or other manure-based products, it's not only creating the dead algae zones that some of the projects alluded to this morning, but it's depleting our soils of nutrients. So Renewable is trying to make an impact on our larger agricultural system. Now, in the world, agriculture, which is either growing livestock or plants, contributes 30% of carbon emissions. From livestock alone, that's 14.5%. So that's a heavy amount of impact on how much pollution is being created just from being able to grow food from our systems. And fertilizer, which is our product, is 3%. So what we decided to do is basically change this very carbon-intensive system, how we source our nutrients, which those mineral salts that a lot of times are all chemical that you guys feed to the plants to help them grow. That's their nutrient or plant food. It's coming from Brazil, it's coming from China, it's coming from very long distance or large distance places to be sourced, and there's a lot of fuel and emissions that are being created to extract it and mine it from these fields so that we can grow our plants in our schools, in our farms today. But there's a different way that we can do that, and that's by using the food waste in our cities so that we can complete one circle, one sustainable cycle, and really leverage local waste streams to grow our food. Because ultimately, we can get the same type of nutrients that you guys have used with growing your food today from more organic or plant-based sources. Now, an alternative to what we use is bats. Bats also have feces, right? Just like cows, just like chickens, just like fish. All of these serve as amazing fertilizer, amazing plant food for our farms and for our lettuce and for our basil, some of the food that you guys talked about you're growing in schools, which is great. But unfortunately, because of how our food systems are so intertwined, and some of the pharmaceuticals or just medicines that some of these animals take, there is a challenge, there is a problem of how that's being also found in our food. So how can we control for that? How can we limit what we're eating so that what I truly believe, as all of us have the power to heal ourselves, how can we use our food as a mechanism to do that? So what we did, as I described earlier, is we pelletize. We basically turn the food waste into small granules and small pellets, and we feed it to the plants so that they can grow the same natural way as they would with the chemical alternative. But as you guys remember, you need a source of nitrogen, you need a source of phosphorus, and you need a source of potassium. Just like we take vitamins and we eat food to be able to grow and reach our healthiest optimum level, plants need the same type of specific nutrients, which is also NPK, short for, at specific points in their life to get to the point that we can grow and actually harvest a full head of lettuce. And as you remember, nitrogen is serving the really big, robust vegetative stage. That's what helps get its early growth. Phosphorus is that flowering. It's allowing the bud, allowing the plants to bud and really kind of like fruit, if you will. And then potassium oftentimes is what gives the flavor, gives the color, allows the plant to get the characteristics that you may know a tomato or even a flowering plant. And so we did the same type of trials that you guys did in your schools, really taking the same pellet that you saw earlier to see if we could make the same type of impact. The plant could grow in the same way at the same end harvest weight as one grown using chemicals. And so far today, we've been able to show that. And so what we really envision is not only a world where cities are more sustainable, we're more resilient to climate change, but we're also creating more of what is called a circular economy. And that means all the waste streams that we create just because we're growing in size, we're consuming more, we're extracting more from the environment in order to make or meet our needs, so that we're using in a way that, you know, we're growing closer in our cities, relying less on food that's traveling long distances, such as in California, so that we have much more of a positive impact and actually can return value to our environment rather than take too much or extract so much away from it. Thank you so much for having me here. I really appreciate the impact.